So we have technology adapters for REST and SOAP, and I'm going to dive into that quite a bit right now. We're going to get into business connectors in the next section. We're going to look at API transformation and how we take the back-end payload and we can optimize it down to just what the client needs through transformation. Show you how we do API testing, and also the ability to create new custom aggregation or orchestration APIs, which allows us to do a lot of orchestration on the back end so the client doesn't have to make a bunch of API calls when they really wish they just had one. We'll talk about how we do API security. We'll talk about a built-in user store in Kony MobileFabric in case you just want to build your users directly in our platform instead of using some existing back-end. And then I'm going to show you how you use our third-party SDKs. We're actually going to go through each one of these so you can see how you can hook into these services easily from whatever third-party tool that you want to use. What we'll be building in this demo is a news and weather app, and it uses Google News, and it'll show world news and technology news, but it'll also show local. And when we go into the local screen, it does a combination of pulling back your current weather, your weather forecast, and also your local news based on your current location. And what's critical here is I want the mobile app to just call one API on MobileFabric and return back everything I want. But if you look over on the right, I actually have to do quite a bit of work. The first thing I have to do is send in a lat long from the device and get back city and zip, and I have to wait for that to complete. But then, if you see that news and weather box right there in the middle, I'm going to call Google News, and then I'm going to call a weather service. And the weather service gives me two different APIs, one to get the current weather and one to get the weather forecast. So I don't want the device to have to call all this themselves. I want to expose one API. So I'm going to walk you through how you create this. And this is where we're going to kind of go through each one of these in detail because I want you to understand the power of the MobileFabric in the middle, that it's not just proxying APIs, it's allowing you to do a lot of optimization and work within the platform. We're in the MobileFabric console right now, and we're inside the News and Weather app. So right where we left off last, we created a new application, and you can kind of see across the top the identity, integration, orchestration, sync, and messaging. So this is where you configure all these different services when you're building a back-end app. We're going to focus on integration right now because we want to connect to existing services offered by Google and Weather and the Geocoding service. So right now we're going to create our first service. This is the news service. It's XML, and then we provide the URL endpoint. So in this case, we're just going to hit news.google.com, and we're going to put a parameter on the end to tell it to give us XML back. So this would be any XML service, REST-based, or even in this case, RSS. And you can see down there the web service authentication. If there is some basic authentication that you want to hard code in the middle, you can. But we'll talk about some more robust security in the next section. So once you specify the URL that you're going to connect to, then you build operations off of your services. So we have a news service, but we're going to create two operations. One to get news for any category, so technology, world news, U.S. news. And we're going to make these operations public for now because we're not going to authenticate to the app. We just want to call these APIs with no security. We're going to come back and secure them later. So this particular operation uses the base URL, but we also specify something extra for this operation where we want to send in a topic to Google, and the $ category is a variable that we're going to accept from the client. So we add a parameter at the bottom called category, and for now we're going to put in a test value of just W, which means world news, and then we can test that response back from Google. And we'll get back the XML from Google, and we can see what they're going to send back to us. But we don't want all of this sent back to the client. So we're actually going to go through and we're going to define exactly what we want the client application to receive, and we're going to use XPath to parse out what we want. So we're going to start by defining a collection, because if you remember, the application has multiple articles that come back. So we're going to need to create a collection to hold all this data coming back because the XML repeats. So we can actually configure the middleware to say this response is going to have a repeating data. So I'm going to create a collection called news list, and the news list is going to contain a record, and this record is called a news item. So I can say this is going to be a record, and then I'm going to define what I want that record to contain. So now I go through and I pick out for each of the repeating news items what I actually want to send back to the client, because Google gives you a lot of information, but on our app, all we really want is a title, a link, and a description. So we're going to go through, and you can see we're specifying the title, and we're saying that's going to be part of the record. We're we're going to go down and look for the next item, which is the link, the hyperlink to read more, and then we put in what the XPath is for that particular item. And it knows that they're all linked together, so you don't have to repeat the same XPath over and over if you don't want to. It's all relative. Or if you do a slash, you can index the entire thing if you want to. So what you'll see is once we've defined our XPath and click test, it actually shows us our output result, which is our reduced payload. So we can actually see what our XPath is going to send back to the device. And if we went through that a little too quickly, you're in luck, because we're going to build one more real quickly. And we're going to do web services SOAP after this as well. So for local news, if you notice there's get news for category operation, but now that we're going to build one for local news, and we're going to specify the parameter as Q for query equals $city. So city name is going to be the parameter that we send in from the device for this particular operation or API. So the point I'm trying to get across here is we create one integration service, and then you can build multiple operations off of that. And if you need to change the way you're calling the URL, per operation you can do that. So we specified city name as to provide a test value for New York, just so we can see what the backend is going to send back to us. And then in the response, the request output, we're going to go through and we're going to define the XPath again. You can see at the top there's a few buttons that say copy, paste, delete. You can actually go back to that original operation and copy all of those XPath and come and paste it in. In this case, we're actually going to go through and just type it all again. And I kind of sped it up because we don't have much time to get through all of this. But as you can see, they go through and they can specify, which means each operation can parse out different data from the back end if it wants to. So we've done our news service. We're going to go through and create another one. Now that was XML. This time we want to connect to our weather service, and this is a SOAP service. So we're going to go through and choose SOAP, and we're going to provide a WSDL. And in this box you'll see XML, SOAP, JSON, Java, which is custom connector. You can deploy custom code, and I'll show that briefly a little later on. Database, and then business adapters is where you can connect to line of business systems like Salesforce, SAP, and even our OEM with MuleSoft, and just pull in their metadata and discover objects, which I'll show later with Salesforce. But in this case, we're going to do SOAP, and we're going to give the base URL for the service, and then we're going to specify our WSDL below. Now with the WSDL, you can either provide a URL or upload the file. And what it does is it downloads the file and it actually inspects what's available. So you can see on the operation list page, it says these are all the operations in the WSDL. So if you're connecting to something like an ESB, you can just start loading all your WSDLs in here, and your integration developer can just choose the operations he wants. So in this case, we're going to do get city forecast and get city weather. This is a good example of where the back end doesn't give me exactly what I want, because I want the current weather and the forecast at once. So first I have to connect to each one of these, and you'll notice on the right it tells me what the service wants. It gives me the XML payload, and I just need to parameterize the zip code that I'm going to send in. So I can really easily pull from the WSDL my what we call a request template, and then easily see what I need to send. So I'm going to send in 30303 for a test, and we also give you this tree view to easily see the XML. And if you click on a node, it'll even give you the XPath if you're having trouble figuring out what the XPath is. So very similar experience now. I mean, we're still dealing with XML. We're still going to have to parse out what we want. If you just want to proxy the data back and forth, you can do that. But typically we find that people do want to parse out the payload and just send back exactly what the client's going to want, and that's converting it to JSON. So anything we're sending back based on this parsing is going to be a JSON object, and I'll show you how you can test and see the exact JSON here in just a little bit. So we're indexing all the way down to forecast result, which is, you can't really see the whole XML, but forecast result's pretty deep in the payload, so the two slashes just allows the middleware just to search for it. And we're creating another collection, and then we're going to add the date and the description and some other data that we need to get the forecast back. And the forecast is in another collection, a forecast for each day of the week, so the next 7 days of data. So this is another example of where we have to go through and create this repeating collection, and then we'll get this nice JSON array back so we can put the data on the presentation layer of the client. So as you can see, the developer just has to flip back and forth between the raw output from below and copy the XPath above. If you use the tree view, you can actually just copy the XML, or you can go down and just double-click the nodes in the XML that you need in this raw view. So once this completes, the next thing we'll do is click the test button. And what this does is it calls the service again. It runs this XPath that we've configured and then shows us in the output result what's going to go back to the client. So now we're looking at the output and we can see that the response is much smaller now. We're just getting exactly what we want. The date, the description of the weather, the low, the high, and the precipitation percentage. All right, so now we have our weather service. One more service and we'll be done building these things. The next one is geocoding. So the first one was forecast, and this is just the current weather. And as you can see in the output result, it's just city, state, and temperature. So that's all we need for our UI. And if you look at this XML, it's so much smaller than what the service was responding. So this is the example of the mobile optimization that we really just want to kind of drive home for you guys. Okay, so now we're down to the geocoding service. And this is just one more REST service. We'll kind of jump through this pretty quickly. But if you look over on the left, while it's just going to go through this one more time to build an XML service, we've got our Google News service for getting news for any category. We've got our local news service for sending in our city and state and getting back local news from Google. We've got our weather service, which has two operations, one to get forecast and one to get the current city weather by zip. And then we're now building our geocoding, which you see it's going to take in two parameters. The first one is latitude, and the second one is longitude. So this is going to be pulled from the client device location GPS, and then it'll send in lat long, and what we're going to get back is the city and state from this reverse geocoding service. So to build this, what you should be seeing now is we're putting in just a test value, a test lat and long for Atlanta, and the developer will be able to fetch the response and see the response again. And once again, we get quite a bit of data, but the only thing we really want is the city and zip code. So we're going to parse this out one more time, and then we'll be done with the services. And then we're going to move on to showing you the orchestration service where we can wire all these things together and expose one API back to the backend. So just one output of zip, one output of city. The first thing I need to do is I need to create a news and weather orchestration where I can send in my city for local news and I can send in my zip for weather, and I can call all those concurrently. So if you look on the screen, we've created a concurrent service that's going to call local news, get city forecast, and get city weather all at the same time. So this is a net new API that'll accept city and zip and call all three of these APIs in the backend at the same time. And then wait for all of them to respond and then send back that payload to the device. But I'm still missing one thing. I still need to do the location lookup first because I don't have the zip and the city from the device. I only have lat long. So I'm going to create a new composite service. And what I'm going to do, this is going to be local all. So this is the actual API the device is going to call. I'm going to mark it public again. But this time it's going to be sequential because I've got to wait for the lat long to be converted to city and zip before I can call everything else. So I'm actually adding the reverse geocoding service, which is just an integration API, and then I'm adding that other orchestration service, news and weather. The screen here is we've got to publish these services out to a runtime. You can see we've got several runtimes connected to this account. We're going to publish it out to the QA environment. Because right now all we've done is configuration. So this is going to deploy it out to our QA runtime and run these integration and orchestration servers on our dedicated backend server. As you can see, it's going through the process of publishing these things out so we can get an idea of how long this is going to take. Once this is done, then we'll get an API key and secret for this specific news and weather app to talk to this specific environment. And then I'm going to show you how you build your client app using those things. Here's the news service. So I want to look and see this get news for category. I want to test it just like a client would be hitting this back-end runtime and see what it's going to get back. So when I click on this news for category, I know that I need to send in a category from the device. I'm going to send in W for world, and I'm going to get back the exact same JSON that the device does. And you can see that it's sending back the specific optimized JSON that we configured. I'm going to show you one more. The weather service, get city weather. So in this case, we just need to send in the zip code to get back the weather. So we're going to put in an Atlanta zip code and see that if we call this API with this zip code, exactly what we would get back. So you can see this is just small JSON that we get back for current weather. Now, orchestration is the same way. You can test your orchestration services here as well. So we're going to do local all, which is the one that gives us everything. Now, the server is going to come back and tell us that if you want to send all the parameters at once, you can. It's giving us an idea of everything that's needed. But we know that by calling the reverse geocode Latin long, we're going to get back city name and zip. So in this case, we're not going to give that. We just know that the device has to send in lat long, so that's what we're going to provide. So we're providing this test lat long for Atlanta, and then we're going to execute this orchestration and let it go and call all those services for us. So it goes out, gets the lat long, turns it into the city state zip, calls news and weather, and you can see we get back all of the data in one JSON. It's formatted kind of strange because Google is sending us back this formatted HTML. But if you scroll to the bottom, you can see the city state that we got back from the geocoding, and you can see that weather data that we got back. So the client now can get everything he needs in this one payload. And that's what we're going to use to build the client app. All right, so this is the app we're going to build. Right when it loads up, it just shows you different categories of news by calling that Google service, and then you can click the link and see the detail. And then if you click local, then that's when it calls the orchestration, and it gets back the weather forecast and the local news all at once and shows you this. So keep this in mind. I'm going to show you in the code how easy this is. So kind of keep this particular use case in mind. All right, so now on to code. So we're in Xcode. I'm going to show you native development in Xcode. This is just a configuration file that we created, as any good developer would, to keep our client key and secret in the name of our operations. We give you the SDK, so you're going to download an SDK which creates this KNY client. This is the initialization code for that. So we just have to initialize our SDK with the client key and secret and a URL. And then this is the code, this is the SDK code that we give you for calling an integration service. So if you want to look at the SDK code, you're obviously more than welcome to do that. Then we create our own helper method to call this. So right here, they're getting the data from what the user clicked, and then invoking get news for category. Here is the callback function. So this is the callback function so invoking an integration service is just one line. You give the service name and the operation and a callback function, and then you build your callback function to process the JSON that's coming back. Now this is the location. In this one we're getting the location and we're calling the orchestration, but it's just as easy. It's just one method, invoke service, you send in your lat long, and then it's going to go and process all of those services in the back. And then it's going to call our callback function, received objects, and then we just have to loop through all that data and put it on the presentation layer. All right, on to Android. So this is Android native, same type of functionality, but I'm going to walk you through what it looks like in Java. And those SDKs, when you download them, they're available in the MobileFabric console to download, or they're available in that cloud portal that you saw as soon as you registered, that first page that you get after you log in for the first time. And obviously all the documentation that needs to go along with that to show you how to use it. So in Android, same configuration file where we just configure our app key, secret, and URL to our runtime environment. We initialize our SDK with the client key, secret, and URL. And we have a callback for the initialization in case something went wrong. And then when you want to load news for a category, we've got a method for that, get news for category. We collect our parameters, such as W for world news, and we invoke the operation with a callback. And then the callback function simply gets the JSON and loops through it and puts it on the presentation layer. And then for local news, pretty much the same thing. That's the callback function, very similar, just slightly larger JSON. The local news service simply just has to get the Latin long and then add that to the parameters that's going to go to the service. So we build that map and send that into invoke service, and then it'll fire that orchestration service. And then there's a callback to put that on the presentation layer. This is the callback function. So I know that's pretty fast, but I think at least the concept of having a method to call the integration service and then a callback is probably pretty straightforward. The next thing we're showing is an iOS app built in PhoneGap. So pretty much looks the same. The presentation layer in this one's obviously built in HTML, but I'm going to walk you through quickly what it looks like in PhoneGap code using our SDK. If you're really looking, you can see some differences because this one's built in HTML versus native. Same thing, Kony Studio you can invoke using the APIs, but the last one is desktop web or HTML5. So we built an HTML5 application that does the same thing. It calls the APIs because we give you a JavaScript SDK as well. So if we look at how this app was built and we look at the JavaScript, there's a Kony SDK JS. That's what we provide you so you can see the helper methods. And then we wrote a Kony Web Workers JS that initializes the SDK and then calls the integration service based on name. And you can see we fire off 4 calls for world, N for national, which is US, T for technology, and then local news. In this case, we just kind of hard-coded Miami, Florida to speed things up. And then we have a callback function for each one of those. So our HTML5 app calls each of the 4 panels in parallel, and then the server comes back and fills them out whenever they come back. So that gives you an idea that it's just as easy in desktop web HTML5 apps as well.